So let's work through an example using animal names. How did we get this pretty picture? Well, 100 people were asked to write down the first word that came to mind when they were given this stimulus word. In this case, animal names. This resulted in the table presented on this slide. It shows the number of times an animal's name elicited another animal's name. For example, dog was associated with cat 57 times, and the response to eagle was bird 27 times. Through the magic of computer software, various measures of centrality of the words were calculated. Dog elicited the most animal names, while cow, cat, and dog were the most common responses. Animal and dog were the closest to each other animal names, and animal had the greatest betweenness. Note that the generic terms animal, bird, fish, and insect had the highest betweenness centrality, but not mammal. Why? Probably because mammal is only used in special cases to differentiate bats from birds and dolphins from fish. All other mammals tend to be associated with the generic term animal. Notice that this network is fairly sparse, with a density of only 0.9. Only 9.2% of the possible links were present. Only 9.2% of the animal terms were elicited by the other animal terms. The animal names were differentiated into a number of groups by the respondents. At the lower left are a group of cow terms: cow, bull, calf, and cattle. The insects clustered on the top right and included spider. The birds formed a group on the top right that included bat, and the aquatic mammals composed still another group with the inclusion of fish. Finally, networks change over time. The relations amongst nodes change over time. For example, people get married and others take new jobs. People join the network and others leave. There may be shocks to the system that alter the relationships amongst the nodes. Animation may be employed to demonstrate how networks change. Let me show you two examples. The first one shows how the international internet bandwidth changes over time. The size of the nodes is the nation's total bandwidth capacity. The color is their location. Europe is in blue, the US in green, Asia in yellow, and Latin America in red. Notice that the relationships are relatively stable, with India bouncing around, eventually resting between the United States and the United Kingdom, and that the size of the nodes in Europe grows. The other example shows the patterns of migration amongst Canadian provinces. The size of the nodes are the province's population, and the color is the season. Blue is winter, green is spring, red is summer, and yellow fall. Note that the pattern is relatively stable, with the network appearing to dilate and contract depending upon the season. If you look closely, you can see Nunavik appear as it becomes a separate province. Oh yes, the audio track clearly shows a seasonal pattern in migration. Listen to the 4/4 rhythm. Migration is great in the summer and low in the winter. Thank you for your attention. I hope this wasn't too painful.